Hello, calculus students. Ms. Deerbeck here to talk about some more calculus graphs. So let's say I have a graph of y equals e to the x and y equals, I don't know, 14x plus 1. And I want to know, where do these graphs intersect? Algebraically, setting e to the x equals 14x plus 1, you can't really get x on one side of the equation, so this is a great time to use your calculator. Now, when I go into, I want to be clear, whenever I turn on my calculator, I clear my home screen. When I go to my y equals, I want to make sure I clear everything out. You'll notice that your equal signs are highlighted. That means that that graph is going to be included on your graph. So we'll go ahead and clear everything out. And if I want to put in a graph of e to the x, you'll see I have e to the x right here. So if I hit second e to the x, using my xt theta n button. And then for my second graph, I hit 14x plus 1. Now, if I just hit graph, I have a wonky window going. So here's my graph. And I can only actually see part of e to the x and part of 14x plus 1. So this is a weird window. So whenever you hit a graph and you hit zoom, in the zoom menu, you have zoom in, zoom out. Zoom square is really nice because you'll notice that you have a rectangular window, so everything kind of gets pulled wide. So if you're trying to actually see what something looks like, zoom square is a great place to be. But also down here, if you're graphing something like cosine or sine, zoom trig makes all of the x ticks, pi halves, pi, 3 pi halves, and all the y ticks, 1, -1. And then there's good old friend zoom standard. Zoom standard makes a window that goes from -10 to 10 and -10 to 10. And hopefully right away you can see that I can only see one point of intersection between these two graphs. So this is not a good window for what I'm trying to find. Hopefully, with a little bit of mental reasoning, you know that anything to the 0 power is 1. So if I plug in 0 on this side, I get out 1. And if I plug in 0 on this side, I get out 1. So they definitely intersect at when x equals 0. So at the point 0, 1, these two graphs intersect. But I know in my heart that there is going to be another point of intersection here. So now is where I want to start to adjust my viewing window. So zoom, again, has a bunch of standard zooms, but if you hit the window button, this is where you get to be in control. So I know that my x value is going to be positive, so I can maybe make my x minimum, I can make my x minimum 0, my x max something like 20, my y mins, now I know it's going to be a really big y value and I know it's going to be positive. So again, maybe if I try 0 to 20, then I'm really looking at a big chunk of the first quadrant. So hopefully, oh yes, so you can see that exponential functions grow really quickly. So making my x's bigger isn't actually helpful. I probably want to make my x's smaller, but my y is bigger. So going back to my window, we'll make my x values go from, say, 0 to 10, and my y values go from 0 to 40, and see if we get it in that window. Oh, there's my e to the x. There's my 14x plus 1, and I still didn't quite get it. So I just go back to my window, and I need my y values to be bigger. So there's my e to the x function. And there's my 14x plus 1. So if I want to find where these intersect, remember that all the good stuff is hiding under that calc menu. So if I hit second calc and I go down to intersect, again, it's going to ask me some questions. By arrowing left and right, I can see which curve I'm on. Do you see? I need to be bigger. Oh, what have I done? Second calc, intersect. Oh, so here it tells me I'm on the e to the x one. I'm on the other one. Do I want to guess? I don't know. I'm gonna guess x is 6. You can guess or just hit yes, please. And it will give you out your answer. So these two graphs intersect at x equals 4.049385, and y is 57. So these intersect at the point 0, 1, and again at 4.0569, comma, 57.797.153, dot, 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 dot. And then you can round it to wherever you have been asked to round your answer. So again, just looking at the equations that I have in here, if I keep e to the x in here, I'm just going to delete this one. I'm going to go back to my Zoom standard. I want to go back to my normal window. We get this little sliver of e to the x. You can see it's really, really small, and then it grows really, really quickly. A couple of other things to show you under the calc menu. What do we notice number 6 is? Derivative. Now my window goes from -10 to 10. So if I enter any x value between -10 and 10, it is going to give me the value of the derivative. So if I plug in 3, there's my derivative. If I plug in 4, there's my derivative. If I plug in 0, there's my derivative. If I plug in -2, there's my derivative. If I plug in 21, it's going to yell at me because my window only went from -10 to 10. All right, so a couple other cool things under the calc menu. Oh, sorry, quit. So a couple of cool things under the calc menu. Following the same reasoning, you can find things like zeros on your calculator. So if I have f of x equals x squared minus 8x minus 4, and I sketch a graph of that, I can see that this graph has 2 x-intercepts. I could certainly solve them by using the quadratic formula. I could try to factor, I could complete the square, or I could go under my calc menu. It says calculate the 0. Now again, your calculator is going to ask you questions. You can see that we have 2 x-intercepts. So you need to tell your calculator which one we're looking for. So if I'm looking for the negative x-intercept and it asks me left bound, x equals 0 is not a good left bound. I need to come up with a region on the left side of the x-intercept and on the right side. So a number less than, and you can certainly arrow around, but it's a lot easier to just plug in -5, enter. And you can see it put your x bound right here. Right bound, well, I need to be on the right side of this, so maybe I hit 5. And then it asks me to guess. Again, if I made my left and right bound have 2 x-intercepts in the region, it's going to give me the one closest to my guess. So my guess is -1, and it's actually -0.721, comma, we know the y value is 0. So go ahead and pause the video and try to find this right-hand x-intercept right now. All right, so again, if we're going to go up to calc, we're going to calc the 0. And again, we're looking for this one over here. My window goes from -10 to 10, so it looks like it's about 8. So I can make my left bound anything. Again, if you arrow along the graph, it just gives you random points. Or you can be in charge and put your left bound is -3, enter. Right bound. You can't go past your window, but you definitely want to make sure you go past this bound. So I'm going to put in 10. Guess? Now you can see my left bound is over here and my right bound is over here. I have to guess to make sure it gives me the one that I look for. I'm going to guess 8. And my actual 0 is 8.47 blah, 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 comma, 0. Under the same menu, you can find things like minimums and maximums. So if I want to find the minimum, hopefully now you're starting to get the hang of how this asks you questions. Left bound. Well, I can see I have a parabola, and I know that my parabola has a minimum value. So let's say between 0 and 10, what is the minimum value? Well, let's put in for our left bound 0, for our right bound 10. Guess? I don't know. I guess it happens at x equals 5. Oh, I was close. Your calculator is actually kind of silly. It's not very smart. It's actually 4. So this, because we understand that it is a vertex, our minimum is the y value. It happens at x equals 4. So this, as we know, is our critical value. This is our extrema. So hopefully now you can get comfortable storing things on your calculator, evaluating things, finding points of intersection, and use your calculator effectively.